Welcome back. In this section, we're going to look at NumPy. And now I'm very excited about this section because NumPy is basically the backbone of all data science, machine learning, and numerical computing in Python. And that's actually what NumPy stands for. It stands for Numerical Python. And what is NumPy? Well, in all of machine learning, no matter what kind of data that you're working with, now this could be a data frame like we saw in the previous section on pandas, NumPy is going to form the foundation of turning your data into a series of numbers. And then what a machine learning algorithm will do is work out the patterns in those numbers. So if we refer back to our machine learning modeling framework, we've got step 1 is problem definition, step 2 is data, evaluation, features, modeling, and experiments. And then if we have a look at what tools we can use, in this section we're going to be focused on NumPy. NumPy comes into the data analysis section. However, as you'll see in the future and what we just referenced before, is that machine learning, although it's referred to as modeling, is essentially taking data, turning it into numbers, and in this case with NumPy, usually the form of a NumPy array, which we'll have plenty of experience with after this section, and then finding patterns in those numbers. So almost across this entire pipeline, NumPy will come into play. Now, why NumPy? Well, the main reason we use NumPy instead of pure Python, I mean, you can do numerical calculations in Python, but usually if we want to do large-scale numerical calculations, we refer to NumPy. It's because it's fast. And now the reason why it's fast is because behind the scenes, there's optimizations written in C code. The beautiful thing about the NumPy package is that you can use these C code optimizations using pure Python. That means you don't have to know C to be able to use NumPy. And Python is a bit easier to write than pure C, so that's the advantage of using NumPy. Now, it gets these optimizations in speed through a process called vectorization via a term NumPy uses called broadcasting, which is essentially just avoiding writing loops when you're writing calculations. Because if you're writing loops to make calculations, such as in Python to calculate over a list, that can form some eventual slowdowns if you have a list, say, of millions of different numbers, which becomes common practice when we're working on machine learning projects. And as we mentioned before, NumPy is the backbone of other Python scientific packages. NumPy actually forms the basis of the pandas package. So what are we going to cover in this section? Well, of course, we're always going to be focused on the most useful functions, the ones that you can start using straight away. We'll have a look at different NumPy data types and attributes of those data types. Now, the main one is an ND array, but we'll have a look at that in another video. We'll look at how to create arrays. Arrays you can think of as a list of numbers. We'll have a look at how to view arrays and matrices. Now, a matrix or a matrice, you can imagine as a combination of different arrays. We'll then look at how to manipulate and compare arrays. We'll then finish up with sorting arrays, which is sorting out different lists of numbers. And then some practical use cases of where arrays get used or where NumPy can be used to turn data into lists of numbers. So, where can you get help if you get stuck? Well, the steps you want to try and follow is to follow along with the code. So as we're going through the video, as we're working through our Jupyter notebook, through the introduction to NumPy lessons, you want to follow along as best you can. Now, if you can't keep pace or if I'm going too fast, that's all right. Feel free to stop it, go back, practice something on your own, but you should be practicing writing the code and running it as much as possible. So that's step 2, try it for yourself, try to run the code. Remember the saying, if in doubt, run the code. If you get stuck on a certain function or a certain thing that we've covered, you can try to search for it. Here you'll probably come across Stack Overflow or the official NumPy documentation. Then after that, once you've searched for it, if you find something on Stack Overflow or the NumPy documentation, the important thing is to keep trying again. Enter the code that you find in the Jupyter notebook, practice running it. If in doubt, run the code. And then finally, if you're still stuck, don't forget, you can always ask for help. There's no such thing as a stupid question, because if you have a question it's likely someone else has the same question. You can ask on Stack Overflow or on any other resource you can find. All right, with that being said, that's an introduction of NumPy. It's the foundation, it's the backbone of other data science and scientific packages, but let's get in and code. Let's see what it's all about.